This conference will now be recorded.
So if you observe yesterday, right, we're discussing about some couple of cases which is related to some name node and metadata, FS image and edit log files, second name node. So what is exactly checkpointing process? These are all things we are discussing, right? Just I'm going to review some couple of points and then we can go for further. So now, if you observe initially, so we have concluded only one point, that is metadata is always going to store only name node. It will not store any physical data, I mean blocks. So whatever the physical data, I mean blocks, it is always going to store in data node. This is the 2 points in which you have concluded initially. But later on, whatever the metadata which is maintained by name node, so it will store in main memory, I mean RAM. So and it is going to do further actions or further related tasks which is related to whether name node or what are the tasks which is asserted by name node, right? So and we have assumed one scenario that, so for suppose if metadata, what are the metadata which is in RAM, or for suppose for unknown reasons if name node is down, so definitely we are losing this metadata information. So then I mean we're unable to I mean once if you are able to restart also we're unable to get this metadata, because if you observe the RAM, whenever the it is processing, then only that a file is going to exist. I mean that metadata information is going to exist. So once if it is that process is down or that process is not there, so definitely we are losing this metadata information. Then immediately we are having a solution called as FS image file. Okay, we're having a solution called as an FS image file. So here while whenever if you're going with this installation part, we discussed one file, that is hdfs-site.xml. Within that file we're having one property, that is dfs.name.name.dir, and if you observe this value, we have configured with this some value, I mean some location. So within that location we are having this fs image file. So importance of this fs image file is, whatever the metadata which is having by name node, same snapshot we are having in this fs image as well. Okay, and then we discussed about, for suppose if I am performing some operations, whether I'm creating a file or creating a directory, or I'm moving a file from local file system to HDFS, some couple of operations I'm doing within the HDFS, let us assume. So here, when this fs image is utilized by when this fs image is utilized by name node is if and only if whenever if you are doing the starting of the name node, or if you are restarting the name node, then only this fs image is going to load into a RAM by name node. But what about this real-time operations? So after starting the name node, right, if I am performing some operations within the HDFS, so whatever the real-time operations we're having, these operations, it will not be reflected to FS image. Okay, so for this here we're having a one more file called as an edit or edit logs files. So what is the importance of this files is, whatever the real-time operations we are doing in HDFS, these all operations it will be updated into this edit log files, not in fs image files here. Okay, so now here this thing is fine. We're having two files, one is edit logs and fs image, and after that we have assumed one scenario that, for suppose around 7:20 I have started my Hadoop, I mean Hadoop process names. So I have done some most of the HDFS operations around 10 minutes. I have stopped this all the Hadoop process around 7:40, and again I have restarted the my Hadoop process names. So now here what Hadoop is going to take it. So whatever the 7:20 we have started the Hadoop, so it is loaded this FS image, right? the same FS image is going to be loaded into 740 as well. But between this 720 and 740, we have done so many changes in this HDFS file system point of view. These changes, it is not reflected into FS image. There is a one more problem we have faced, right? Or one more scenario. For this scenario, what we are having is we're having a concept called as in checkpointing process. So what is the importance of checkpointing process is, so this what are the edit logs files we're having, and whatever the latest FS image we're having, this all edit logs files is going to match with this latest FS image file, and which it is going to create a new FS image. Okay, within this new FS image, all the real-time operations or whatever the modifications in which you have done in HDFS, all these things it will be referred into this new FS image file. So whenever this name node is restarted or whenever this name node is started, this new FS image file is going to be loaded into the RAM. Okay, this thing also we have discussed. And after that, we have assumed one more scenario. That is, let us assume, so name node is not down, or we did not restart the name node around 60 to 90 days. Then we're having a huge number of edit log files. Okay, so edit log files are very huge. So, but whenever if you are restarting the server, maybe around around 65 days, so this checkpointing process is going to done by name node. Initially, we have given a statement. Whenever if you are, name node is going this checkpointing process. So name node is too much busy in doing this checkpointing process. It may take some couple of hours. So whenever now this checkpointing is process going on, so if you have got a request to the Hadoop cluster, so initial request will go to name node. So name node was unable to provide the response back to the client because name node is busy with this checkpointing process. So in order to overcome this scenario, so we're having a one more uh, name node, or what we call not excited name node, one more Hadoop cross name. There is nothing but a secondary name node. So by using secondary name node, what is the advantage is whatever this checkpointing process is done by name node. So first of all, second name node will going to communicate to name node. So it is going to take the latest FS image file, what are the FS image file it is having. So it is going to take this all the edit log files and it is going to match with this FS image and it will produce a new FS image file. This new FS image file, it is again back to the name node. I mean, this process is not done by name node now. This entire process is shifted to secondary name node. And secondary name node will not act as a backup of name node. This is very, very important point. Okay. Just it is going to do the checkpointing process. That's it. But it will not communicate to either data nodes or second name node don't know where exactly this list of blocks it is available. Okay, by using this list of blocks, it will not construct the file. Whatever the points which are discussed in name node, all the points which is not done by second name node. Only just it is going to maintain the metadata or snapshot of metadata and checkpointing process done by second name node. Okay, so is these points are clear till now? Whatever things which are discussed. Any doubts on this? Okay. I think yesterday till case 2 we have discussed, right?
This conference will now be recorded.
Now if you observe here, right, what is happening? What are the points? Yesterday we have summarized the same thing here. Okay. So second name node will take this FS image and all these read logs, read log files in regular intervals, and it will update the FS image, and again it will copy this FS image to name node here. Okay. So now case 3. case 3. Now if name node goes down before checkpointing process. Okay, if name node goes down before checkpointing process. Okay, then all the operations took place after last checkpoint will be lost. So this is one more scenario what we are having. Okay, now if name node goes down before checkpointing process, so then all the operations took place after last checkpoint will be lost. So is this point is clear first of all, or any confusion? Let me know. So are you getting the difference between case 2 and case 3 first of all? If not, let me know, all of you. So you need to read this statement couple of times. Now if name node goes down before checkpointing process, then all the operation took place after last checkpoint, okay, will be lost. Is this statement is clear first of all? Take some time. And any of you can explain this difference between case 2 and case 3? Any of you? What is the difference between case 2 and case 3? Any of you? You can talk with me. Just couple of lines I am expecting from you for case 2 and case 3. What is the difference?
I understood that in case two, if we have a situation where a checkpoint operation did not occur for the last 60 days, and in case three, it is like if name node goes down before the checkpoint process.
No, in case, first of all, in case 2, what you have understood?
Uh, yeah, in case two, uh, if the checkpoint operation did not occur for the last 60 days example, then
Mm-hmm.
it will not have the backup, right?
Mm-hmm.
So
So it will not be
yes,
backup means?
so the FS image file will not have the updated information of the
Mm-hmm.
operation.
Mm-hmm.
So name node will use the secondary name node file to
Mm-hmm.
get the information.
Mm-hmm. So you need to observe one point is, so what you have understood is somewhat fine, but not completely. So here, if you observe the case 2, majorly here we have taken the scenario as 60 days. And if name node is doing the all this checkpointing process, what is the problem is name node was unable to survey the, unable to provide the a response to the client. That is a major scenario what we're having in case 2. Okay, so now here, if you go with this second name node, what is going to happen is, so around 60 days, let us assume we're having some 500 edit logs. Okay, now name node has to do this, all the edit log files, it has to merge with this name, with this, with fs image means it will take some couple of hours. Instead of that, so what this second name node is doing is, at regular intervals of time, okay, at regular intervals of time, whatever the edit logs files it is having from name node, this all the files it is going to match with this fs image, and it will produce the new fs image. Whatever the checkpointing process is there, same process is going to done by second name node, but checkpointing process is measured done by only name node. But you can assume that it is a same process, not exactly checkpointing. This is the same process which is done by second name node, but at regular intervals. For suppose we have assumed that 60 days, right? So each and we can configure like this. Okay, in if you go, I mean, even administration level, you can configure like this. Every 1 hour or every 1 minute or even seconds also you can do it. You can do it as so. Second name node will take this all the edit log files and it will match with this fs image and it will produce a new fs image. But suppose I have configured as a every 1 hour. Okay, whenever this process is repeating by second name node, so then there is a no chance of I mean there is no chance of edit log files. I mean huge edit log files will not be there. If you take, if we have assumed that 500 edit log files in 60 days, now whenever the second name node is doing for every hour, so definitely edit log files is going to reduce. Is it yes or not, all of you? You got my point first of all? Yes. So now there is no button to the name node. So some button is reduced to the name node. But here what is the problem is whenever this name node is restarted, okay, so we have assumed that second name node is doing this all this process, what are the process which I have explained you. Now edit log files, it may be some, finally it will reduce it to maybe some, assume that 5 or 10 edit log files out of the total, right? Out of the 500 edit log file, reduce it to the 10 or I mean 5 to 10 edit log files. Now we have restarted the name node. So name node is again doing this checkpointing process. I mean merging of this edit log files with latest fs image, and it is producing the new fs image, and again it is reloading this new fs image to the RAM. I mean main memory. Now it is doing all the respective actions which is performed by name node. It is doing its own functionality now name node. But before, now if you observe here the statement, now if name node goes down before this checkpointing process, okay, then all the operations took place after last checkpoint will be lost. Okay, so last checkpoint, let us assume it is done on July. Okay, now it is doing all this checkpointing process, means this August, September, this information, complete this metadata information is going to lost once again. Now is this point is clear, all of you? Abdul, Amit, Babu, Rakesh, Suresh, Etin, Bhagat.
Sure, this also sounds like a 60 days issue, right? Uh, if the checkpointing process not running for the past 60 days, like you said, from
No,
July.
no, no. Here, within the 60 days, first of all, second name node is going to do all these things.
Yeah,
Yes.
yeah. Anyway, in both the cases, secondary name node will be updated, right, with the latest image,
No, no,
FS
no, no.
image file.
Here, whenever if you are doing this name node restart, okay, second name node will not come into picture. Name node will do all the checkpointing process, first of all.
Okay.
What is important of second name node is, so here we have assumed that 500 edit log files, right?
Yeah.
This 500 edit log files, whenever if you're doing with name node restart, this 500 edit log files itself need to merge with this latest fs image file, and it need to produce new fs image file. This process is going done by name node. But whenever if this process is done by name node, so name node is like I mean name node is going to be busy and it was unable to survive a response to the client. That is the reason what this second name node is going to do is each and every hour it is going to make all these edit log files, it is going to merge with fs image and it's going to produce new fs image. So this all this process is going to done every hour, means we are having 24 hours. So within a day it is going to done 24 times. So whenever it is going to be 24 times means definitely edit log file is going to reduce. So that what is the advantage is we are reducing so much of button to the name node. Now there is a chance of providing response to the client. Is this point is clear, Abdul?
Yes.
Yes. Still any? Suresh, is it fine for you? Okay. I hope it is fine. Okay, still if you're having any, let me know. Okay. So solution. So we need to consider a backup node which maintains a real-time backup of the name node states of the name node's state. Okay, so we need to consider a backup node. So here just assume we're having a one more process name called as a backup node, but till now there is no chance of implementing this backup node. Okay, but we're having a concept, that's it. So we need to have a one backup node. Okay, so which it is a, just we can say that it is a real-time backup of name node. I mean whatever the changes, so we have assumed that metadata changes, these all these changes, it will be same at the same time within the fraction of seconds, same changes, what are the changes which is happening in name node, that it will reflect to the backup node as well. Okay, it will reflect to the backup node as well. But what about this secondary name node? If you're going with a secondary name node, so just we have assumed that for each and every hour it is merging this all edit log files with this fs image, and it is producing the new fs image, right? This process done by secondary name node for every hour we have assumed. Okay, so now assume that now 8 o'clock need to do, I mean second name node has to do what are the process which I mentioned you. Second name node has to do its process at 8 o'clock, but around 7:45, okay, so name node is down, means so 7 a.m. to 7:45 a.m., around 45 minutes. So definitely we have got some edit log files. Okay, definitely we have got some edit log files. So now whenever this name node is down, okay, so you know that entire cluster was inaccessible. I mean no further operation can be done. Okay, then what are the processes we're having? Okay, so now what about the second name node? Second name node was unable to do this operation. I mean second name node was unable to do its duty because entire cluster was inaccessible, and it was not do further. So now whenever if you are doing this name node restart, now what name node is going to consider? Already fs image file is there, right? Which is done by second name node around 7 o'clock. That fs image file is going to be loaded to RAM. But what about this 45 minutes edit log files? There is no chance of, I mean we are losing that information, right? What I mean to say. So that is the reason. So they have initially they have considered as a backup node, which is a real time. For suppose if name node is done around 7:45, right? Still 7:44. So 7:45, even if you are considering some microseconds as well, right? So 7:45 is done means till 7:44, whatever the information which is having a name node, this all information will be reflected to backup node as well. This is a real time. Okay, there is no chance of delaying in hours or even minutes. Real time data will be there in backup node. Okay, so is the
Uh,
difference is fine, all of you?
yeah, sure. Is this backup node is another name node?
No, 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 not a name node.
Okay. Do we have any specific name for that, or it is just a backup node?
Yes, it is just a backup node. That's it.
And
You can
it
assume it as a, sorry.
And this will also have the same metadata, correct?
Yes.
Okay.
But still we are not implementing in real time, but this is the scenario what we are having. Okay, what they have assumed, I mean, while developing in the we'll go with so currently we're having, they're releasing this Hadoop 3.x as well, I mean alpha version. Okay, so but whenever they're releasing before this, initially they're having Hadoop 1.x, after they want to release Hadoop 2.x. So whenever they want to release Hadoop 2.x version, so these scenarios it is happened. Okay, what I mean to say, but they did not provided a new process name called as a backup node. If you observe the job tracker and task tracker, right, it is a Hadoop 1.x, but they have provided a two they have renamed these process names as resource manager and node manager, right? So why they have changed these things is because they have implemented a concept called as a AN, YARN, at another resource negotiator. Okay, which is a new concept in 2.x. Okay, not in 1.x, it is a new concept in 2.x. So they have got they have changed drastical changes, so in performance or resource allocation point of view internally. That is the reason they have implemented a new concept called as a AND. But based upon this backup node, they have not implemented any concept, or they did not they did not created a new process name as a backup node. Okay, or simply we can say that, so they did not written the source code, because this is completely a, if you observe the framework, they have developed a complete API, right? They did not return any API for this backup node, just they have assumed that thing, just I'm telling here. Okay,
Okay, got it. Thank you.
so but if we are using, the backup node, we can't run the checkpoint node or secondary name. Okay, so if you are using the backup node, we can't run the checkpoint node or secondary name node. Okay, so here what they feel, what this Hadoop, uh, whoever the inventors of Hadoop, Docketing is inventor of Hadoop, but within the Docketing, they're having a huge number of teams, right? Which need to, they develop their own API, means they're having a huge number of developers. So maybe if they think that, so for suppose if they introduced one more backup node, so complete, there is a drastical changes in the Hadoop architecture level as well. Okay, so now here having is some architecture we are following, so which I've explained in previous classes. So this architecture has to be redefined once again, which is a lot of API changes has to be there. And what I feel is, what as a trainer or as a developer, what I feel is, so if even though if they implemented this backup node, there is no use in this, because anyway, let us assume, so name node is down at any point of time. We don't know exactly when this name node is going to be down, right? Definitely name node is going to be down at some point of time. So even though if you're having some backup node, right, what is the use of that? Because it is a not a whatever the process or whatever the actions or whatever the functionalities which is done by name node, so these things it will not be done by either a second name node or backup node. But what is the advantage we're going to get is, for suppose same name node, if you're having a one more name node, okay, just whatever the functionalities or whatever the tasks or whatever the actions which is done by name node, same thing we're having a one more name node, means then there is a chance of, we're going to get an advantage. But backup node is not acting as a name node. So simple, what a second name node is doing, same process, same thing we are achieving, Only difference is, so it is a real time. It is not a history. We can take it as an history level. If you observe this edit logs, right? So second one is just assume that we are doing as every 1 hour means. So within 1 hour, edit logs has to generate, and this edit logs is going to matching. I mean, history of edit logs is matching secondary name node. But if you observe this backup node, it is not like that. It is a real time. Whatever the changes, if it has happened within the seconds or within hours in the name node, the same thing it will be there in backup node. But it is not a process backup. It is not a process backup. So that is the reason now we are going with the case 4, which is a lost scenario. So which you are going to get a complete clarity. So now case 4. Now everything is fine. Everything goes fine until name node is running. If something goes wrong with the name node and it goes down, then the entire file system goes offline and HDFS cluster is unavailable until restarted manually. So that is the reason in Hadoop 1.x we are calling name node as a single point of failure. Okay, so that is the reason in Hadoop 1.x we are calling as a name node as a single point of failure. At any point of time, there is a chance of, name node will be not name node goes down at any point of time. We don't know exact that scenario as well sometimes in real time. So, but what happened is whenever they are developing this API, they have assumed so many scenarios. What are the scenarios in which you have discussed till now? Okay, so they have developed one more second name node and they have maintained this metadata. All these things they have done so many things, but at any point of time, if name node is goes down, so definitely client was unable to get the response, or client was unable to get the enough information from the Hadoop cluster. Okay, this scenario at any point of time it is going to be happen. So forget about this metadata, this rate loss approximate, these all these things. But at any point of time, if this name node is down means we are unable to access the entire Hadoop cluster. That is finally they have got, this is the thing. Even though they're doing this all this metadata backup by using this second name node checkpoint because each and everything is fine. But at any point of time, if name node is down means definitely we are unable to access the Hadoop cluster. As an end user or as a developer, we also don't know where exactly data is present in a multiple machines or a data nodes. So finally, they have mentioned as a named as a single point of failure in Hadoop 1.x. Okay, so solution for this is in Hadoop 2.x they have introduced a new concept called as they have introduced a new concept called as high availability. They introduced a concept called as a high availability future. So what is the advantage of this future? High availability future is, so at the same time we're having two name nodes. Okay, at the same time we're having two name nodes. I mean, one is add to node and one more thing is standby node. So it looks like this.
This conference will now be recorded.
So this is the image of this high availability architecture, I mean HDFS. So here if you observe, we're having it two name nodes. One is add to and one more thing is a standby. So both are having a common metadata, that is nothing but by using a general name nodes. Okay. So this is nothing but a add to name node and standby name node. Okay. So both are communicating with these general nodes because they want to get a real-time metadata information. That is the reason. And both, if you observe this add to name node and standby name node, both are having this data nodes, and add to name node is going to communicate with these three data nodes and even this standby name node as well. So now, even though if one name node is down, so the another name node is going to provide the request and response to the client. I mean, within the Hadoop cluster, if you're getting some request from client, so definitely we're going to get the response back to the client. Okay, so this is a new feature which they have introduced in 2.x. Okay, that is a final solution what they have provided. So these are the number of scenarios which are discussed till now. Okay, or otherwise even you can for suppose if you are facing some interviews, or if the interviewer is a really technically strong person, even they can they may ask like this also, what is the reason to go for high HDFS high availability. So these are the scenarios what we're having. So if you expand these scenarios, so definitely that interviewer is impressed with you. Okay, so is this concept is fine all of you? Okay, so let me summarize some points which is related to this high availability. Okay, high availability concept. Then you're going to get some more awareness on this high availability. High availability concept in Hadoop. So before Hadoop 2.0.0, the name node was a single point of failure in an HDFS cluster. Each each cluster had a single name node, and if name node fails, the cluster itself down. So the concept of high availability cluster was introduced in Hadoop 2.x to solve this single point of failure problem in Hadoop 1.x, or we can say that Yes, in order 1.x. So now if you observe, HDFS follows master slave, these things we discussed, master slave architecture, where name node acts as a master daemon and is responsible for managing others slave nodes called as data nodes. This single master daemon, I mean name node, the single master daemon or name node becomes a bottleneck. Okay, because if is the only one daemon which is going to, I mean, is a head for everybody, simply can say that he is a head for everybody. Let us assume in our startup companies, or if you go for any other level 3 companies, not MNCs. So if a single person, he is handling some 6 to 7 projects, right? 6 to 7 project means, so he is going to call as a bottleneck of these projects. And even in top level, I mean, project manager is going to fear, so if this person is left from the company, right? So how he can handle these 6 projects? Finally, project manager is responsible, answer to their higher officials, right? But suppose if this project lead is left from the company, so how he can handle, I mean, project manager had to handle the 6 to 7 projects. It is so much of burden to him as well. And this project lead is nothing but, they can call as an, he is a bottleneck for these 7 projects. Okay, so even though if new resource came for this handling of these 7 projects, he's going to take a huge amount of time. So that is the reason what they will do is, immediately these projects, what are 6 to 7 projects we're having, this projects will be divided and it will be allocated to some other person as well. Even though if this person is left from the company, slowly they can reduce the burden, and it can handle with other resources as well. Okay, same way here. So name node is a bottleneck. Although we are having secondary name node, we can prevent us from data loss and offloading some of the burden of the name node, but it did not solve the availability issue of the name node. Okay, so we can simply, I mean, I can simply tell these points and I can go for this high availability concept. Okay, but these many of scenarios, why I have teached is, so you need to get the concept, what is going on at back. Okay, simply these points are enough. Okay, although we're having a second name node, we can prevent us from data loss and uploading some of the content to the name node. But the single point I have explained in some 2 to 3, I mean 1 to 2 scenarios, but it did not solve this availability issue of the name node. That is the reason we're going for high availability. But so if you go with these many of cases or these many of scenarios, now you're going to get a complete picture. What is the reason go for this HDFS high availability, and what is exactly second name node and this check pointing process, and whatever things which I've discussed till now. Okay. So that is the reason we are finally going with this HDFS high availability concept, and even I have shown you this diagram as well. Okay. So is it these points are fine, all of you?
This conference will now be recorded.
So is 1.x being used in any of the organizations? So currently not they are using. They are not using with 1.x, they are going with 2.x version only. Okay. So most probably, okay, so I mean, even startups only they will go with this Apache Hadoop. Okay, so most of these MNCs or some level 3 companies, so definitely they will go with this Hadoop distributions. Okay, Hadoop distributions. So nothing but Cloudera or Hot and Works or even HD Insights, AWS, EMR. Okay, so like this, so many things. These are nothing but a Hadoop distributions. Okay, so here, if you go with AWS EMR, nothing but completely they will set up the Hadoop cluster in cloud environment. Okay, even if you go with HD Insights, this is nothing but a from Azure, Microsoft Azure. This is a distribution from Azure. So they also do the same thing. They will set up a virtual Hadoop cluster in cloud computing platform. Okay, so now most of the companies, so I mean, if they are not a startups, so they're going with either one of these distributions. What are the distributions which I mentioned you? So what is the advantage of these distributions is, so definitely they will be up to date in the market. I mean, they will not use sort of 1.x, 2.x, 3.x, whatever the versions we're having. They will not use means, so they will first of all they will not go with this Hadoop 1.x. What are the latest updates which is happening with Apache Hadoop organization, because he is a main Apache Hadoop is the main main organization, so they can introduce they can introduce a new versions or further enhancements of the Hadoop version. Simply you can say that further enhancements or new features, whatever the limitations we are facing in existing version. If you observe this Hadoop 1.x, we are facing some limitations. So this is a major limitation what we are facing. So they have released a new concept HDFS high availability in 2.x. Same way in 2.x also we're having so many limitations. They will all come in Hadoop 3.x. So whatever the versions in which they are providing, once they have provided some 10 versions or 11 versions, 12 versions, finally they have got, they have their product, Apache Hadoop product is going to be stabilized. So now if you observe Oracle, maybe they're having Oracle 14c or 12c. So I think they're having Oracle 12c. So initially they're having so many versions, but in Oracle 12c, after that they did not provide latest version immediately. So almost it is 3 to 4 years back. So even now they did not release a new version related to Oracle, because the product is almost it is in a stabilized version. So now they no need to worry about this thing. But still, even though they're having limitations, they will take some time to introduce the new version. Here also same for Hadoop. So Hadoop is at a beginning. Now it is a 3 months, it is a very initial levels only, initial versions only. So they, each and every year they need to plan, they will definitely they're going to plan one version in once. If there is some Hadoop 8 or 9, so definitely product is going to be stabilized and with so many new features, and what exactly clients are expecting, they will be full-fledged by Apache Hadoop. But here whatever the each and every version they're having, right, so many features, that real-time update will be there. So they will update immediately by these distributions, whatever the distributions we have, because these distributions are used by so many companies. They need to be updated whatever the changes which is done by Apache Hadoop. Okay, that is the only advantage what we're getting with this distributions. And one more thing is, so we don't have installation part, and we no need to configure this Hadoop or Hive anything. So just they're having option called as a, they're having some drop down called as a start and stop. So if you click on the start, so definitely Hadoop is going to start, or Hive is going to start, or maybe something, maybe some peak or HBase, anything. So they're going to start, and if you stop, if you click on stop, it will going to stop in fraction of seconds. This is going to happen within the fraction of seconds only. And finally, they are going to get a complete dashboard. So which data node is down, which data node is running, how much CPU they are using. All this complete information, memory processing, each and information is going to display that dashboard. So that is an advantage of going with these distributions. Okay. Okay, most of the companies, they will go with these distributions as well. So if you're going with a startup, so we're going with this complete end-to-end installations, or I mean Apache Hadoop installation, Hive, Peak, HBase, these all installation we go in there. And once we got conclusion from that, okay, so now I'm going with Apache Hadoop. Okay, I can get, whatever my requirement is there. So my requirement I have achieved from Apache Hadoop, whatever the requirement I'm having. So or I'm achieving by through Apache Hive. So once if I requirement is fulfilled from my end, and even this client is satisfied, okay, then it depends upon the client. So client, he can go with a cloud computing platform, I mean cloud solutions, or no, I don't want to go with this cloud. Just I can, you can maintain the physical infrastructure. I mean, client don't want to share the data to the end user. Let us assume some banking clients is there. So definitely bank client, they never ever share the data to any third party vendor. I mean, if you're going with a Cloudera is a third party vendor, or Hortonworks. These are the third party vendors, right? Where the data is going to be reside in their servers, so that that it will not be asset by client. Then what we need to do? Definitely, we need to maintain the physical, physical Hadoop cluster. So that data itself, it need to be stored in a physical machines. I mean, physical data nodes. So now there is no chance of going with this any of these distributions. Okay. So many of the banking clients, they don't want to share the not so many. No banking client has to share the data to third party vendor. Okay, that is the reason now, even if you're having, if any banking that is implementing this Hadoop concepts or Hadoop related environments in their respective companies, they will go with a physical infrastructure. I mean, physical Hadoop cluster only they will go. They will not go for any cloud computing solutions, or whatever the distributions we're having, until unless they are providing a high-end security to their data. So most of the cloud solutions, if you go with Azure or AWS or GCP, Google Cloud Platform, they're not at, I mean, they're providing the security, but not at high-end security. Nothing but what we can call as a encryption and decryption algorithms level security they are not providing. So that is the reason now, even banking clients, they are not going with this, cloud computing solutions. Okay, so because there's data is a, I mean, there, whenever if you are a, if you are a user to any banking clients, right? So while registering or while filling up the form, right, they will mention each and everything, privacy policies, data security, is all these things they need to follow. There is no chance of sharing this data to the end user. Okay, very sensitive data, this thing. So that is the reason banking rights, they are not following with this either cloud computing solutions. Still, this Azure and Amazon, even this Google, they are working with high-end securities. How they can provide end-to-end security for this banking related informations. Okay, still they're working on, most probably. So this banking data also definitely they will move to cloud platform at one day, but it will not uh, take immediately, but still they're improving their products, both this Amazon and Azure and Google, they're improving their products, providing for the end-to-end security. Okay, so
This conference will now be
one question
recorded.
from Amit, that is, standby name node is a different machine? Yes, so you can configure different machines. Name node is one machine. Add to name node is one machine, and standby name node is in another machine, like that. Okay.